Hey everybody, Mr. Covey here, and I'm going to go over all the problems on the practice test here. Okay? So starting with number 1. It's asking me to solve this equation. All these questions are asking me to solve equations. Okay? So when I look at this equation, the first thing I notice is it's got a lot of exponents, and they're all added or subtracted, the different terms, and there's 4 terms. Whenever I see 4 terms, it's a lot of terms, I'm thinking I'm going to have to use factoring. Okay. The nice thing about this is it's already equal to 0, which is good. And so I'm going to start my factoring. I'm thinking because I have 4 terms that I might need to use grouping. That's the factoring strategy when you have 4 terms. Before I do that, remember that every time you factor, you should first ask yourself, is there a greatest common factor? Is there a GCF I can take out of all 4 of those? And in this case, there is. What do these all have in common? They all have an x in common. So I can take an x out of each term. And then the thing I'm left with still has 4 terms. And I'm going to look at these 4 terms, I'm going to factor them by grouping. Remember, for grouping, you group together the first 2, and you group together the second 2. When you look at that pink group, you take a GCF out of the pink group. What do those have in common? X squared. What am I left with? X plus 5. You look at the yellow group. What do those have in common? What's the GCF? Negative 3. What am I left with? X plus 5. Okay. Then remember that means that the factors are x squared minus 3 and x plus 5. And don't forget, we still have that x out there, and it's all equal to 0. At this point, sorry guys. At this point, I'm done factoring. Okay, I have it factored. Remember, to solve an equation with factoring, you take each factor and you set it equal to 0. So I'm going to set x equal to 0. Well, that's done. That's one of my answers. I'm going to set x squared minus 3 equal to 0. I have to do a little bit of algebra here. I'm going to add 3 to both sides. I'm going to square root both sides, and I'm going to remember my plus or minus. So I get plus or minus the square root of 3. And I'm going to set x plus 5 equals 0. And then we get x equals negative 5. Okay. And those are my solutions. 0, positive square root of 3, negative square root of 3, and negative 5. Okay. Equation 2. This is a radical equation, a square root equation. You'll remember that to undo the square root, you're going to use squares. You're going to square both sides. But before you do that, you got to get the square root by itself. So the first step here is I'm going to add 9 to both sides. Once you have the square root by itself, how are you going to get rid of it? You're going to square both sides. If you want to think about doing this thing we talked about where we made it a 1/2 power, and the way to cancel the 1/2 power is a 2 over 1. So then you put the other side to the second power as well. That's the same idea. Okay. The important idea is you have to do both sides to the second power to cancel out the square root. Okay. What you're left with on the left, here, I'll come up over here, is 9 minus 4n. On the right, you have 7 squared, which is 49. Now I just need to solve this equation and you get the n by itself. I'm going to subtract 9 from both sides. Oops, sorry guys. And then divide both sides by negative 4. And I get n equals negative 10. Remember, with square root equations, it's possible that it's extraneous. In other words, it's possible that when you plug it back in here, it doesn't work. It makes the square root of a negative, which you can't do. But in this case, it totally works, so we're good. Yeah. 3. Quadratic. I got an x squared. Okay? Because I have an x squared and I also have an x term, I'm going to try and use factoring. Before I use factoring, I need it to all be equal to 0. So I'm going to add 19x to both sides. I'm going to be left with 3x squared plus 19x plus 20 equals 0. I should look for a GCF. Is there something I can take out of all the terms? There isn't. So instead, I'm going to factor it, but because I have this number in front of the x squared, it's going to be that hard factoring. So I'm going to look for two numbers that add to 19, but they multiply to 60. Why multiply to 60? Because remember, you got to do this times this to figure out what they multiply to. So I'm looking for two numbers that multiply to 60 and add to 19. You can use your calculator to help you. So you get 15 and 4. It's your two numbers. Okay. And remember, we're using that split the middle technique. So I'm going to split that 19x into 15x and 4x. Bring down the 3x squared. Bring down the 20. And now, remember, when you're doing split the middle, what you really do is making it into a grouping problem. Because now you have 4 different terms. And so now you're going to factor this by grouping. Group those together. Group those together. The GCF of the pink is 3x. The GCF of the yellow is 4. My two factors are 3x plus 4 and x plus 5. Don't forget we're solving equations here. So when you're factoring, you're just like doing a part of that process. When you're done factoring, you're not done with the equation. You got to take each factor and set it equal to 0 and solve. So I'm going to set 3x plus 4 equal to 0. And I'm going to solve that. That gives me one of my answers. And then I'm going to take x plus 5 and set that equal to 0. Subtract 5 from both sides. That's going to give me my other answer. Cool. Okay, moving forward. Flip the equation here. There's no x squareds, there's no square roots, there's no fractions, there's nothing fancy. This is a linear equation. Okay. I'm going to distribute, combine like terms, move it all over. Not too bad. 4x minus 4 plus 4 equals 2x minus 10. I'm going to combine the minus 4 and the plus 4. That's just 0. So we get 4x equals 2x minus 10. I'm going to move the x's over to one side. So I'm going to subtract 2x from both sides. And then the last step, I'm going to divide both sides by 2. And I'm going to get x equals negative 5. Fifth equation here. It's got an x in the exponent. It's an exponential equation. Okay. You'll remember that the way we solve exponential equations is we use logs. Okay. I'm going to convert this into log form. You don't get a note card on your test as we run over. Something going forward in your math career that you need to know is this little relationship here. Okay? Please memorize that. Okay? Put in some time and memorize that. That's how you convert between exponentials and logs. We have an exponential. It looks like this. We're going to make it into a log that looks like this by moving around those puzzle pieces. Okay? So I'm going to have a log. The base of my log, if you look at our little pattern, is going to be 20. The argument is going to be 15, and on the other side is going to be x plus 9. Remember that log base 20 of 15 is a number. 20 to what power is 15? I don't know what this number is, but my calculator does. So grab your calculator and type that in, please. I got 0.904. I'm not done yet because that equals x plus 9. So then I have to subtract 9 from both sides. You get x equals negative 8.096 as our answer. Sixth equation here, I hope looks familiar. This is from our rationals unit, our last unit, okay? It's not a fraction equal to a fraction. It's not a proportion. It's a little more complicated. It's a fraction minus a fraction equals a fraction. Okay? How do you solve this? I need to use that LCD technique. I need to clear the fractions. Look at the three fractions. Look at the three denominators. What's the least common denominator? Well, it has to have an r squared, and it has to have a 3. That's my least common denominator. I'm going to multiply each fraction by 3r squared on top. Every single fraction gets that on top. Be careful about this one. It should look like this. Then remember, the whole purpose of this strategy is that it gets rid of the fractions. So what I should do now is I should simplify. And each fraction, the denominator should cancel. And so in that first one, the r squared and the r squared cancel, just left with 3. In the second one, let's be careful here. The 3r cancels with the 3 and one of these r's, but one of them still left because I had an r squared. So I'm left with 3 minus just regular r. And then the fraction on the right, this r squared cancels with that r squared. I'm left with r minus 5 times 3. The equation I have here now is a linear equation that I know how to solve. Nothing fancy here. Okay, I'm going to distribute the 3 in. I have 3 minus r equals 3r minus 15. I'm going to get the r's over to one side, the numbers over to the other. So I'm going to add r. 4r minus 15 equals 3. I'm going to add the 15. I get 18 equals 4r. And then I'm going to divide both sides by 4. Okay. You can simplify that fraction. It's 9 halves, 4 and a half. Done. A couple more equations here. This one's got an x squared in it, but it doesn't have an x. So it just has an x squared and numbers. I can solve this using square roots. I'm going to try to get the x squared by itself, and then I'm going to square root both sides. In order to get the x squared by itself, I'm going to subtract 8 from both sides. I'm going to divide both sides by 6. You can use your calculator. And lastly, to get rid of the squared, I'm going to square root both sides. Don't forget the plus or minus. I get plus or minus the square root of 58. I can't break down the square root of 58. I'm just going to leave it right like that. Okay. Last equation here is the system of equations. I have 2 different equations. Okay. There's a few different techniques you've learned about how to solve this. Substitution, elimination, graphing. The way this is set up, I'm going to use elimination. What I'm going to do is add the 2 equations together and hope that one of the variables cancels out. What you'll see for this one is if you just add these 2 equations together, I'm going to have 6x plus 4. None of the variables are going to disappear. None of them are going to be eliminated. So what you need to do is change one of the equations so that when you add them together, one of the variables goes away. The easiest way to change one of the equations is just, I want that 2y and that 2y to cancel, so I need one of them to be negative. So I'm going to take the top equation and I'm going to multiply the entire thing by -1. That's going to change it to be negative x minus 2y equals -2. Now what I can do is add these 2 equations together. 5x minus x is 4x. 2y minus 2y, oh, the y's go away, okay, which is what I wanted to happen. Now I only have one variable. -6 minus 2 is -8. Now I have an equation that just has one variable, and I can solve this. Divide both sides by 4, you get x equals -2. Please remember for these ones, it's asking you to find the point where these two lines intersect. It's a system, so you got to solve for x and y. I just figured out x. To figure out y, I'm going to plug that x back into one of my original equations. You can plug it into either one. I'm going to plug it in the first one. X plus 2y equals 2, and I'm going to solve for y. Add 2 to both sides. Divide both sides by 2. I get y equals 2. Okay. I found my x and y. It's nice to write your answer as a point. So the point would be x is negative 2, y is 2. And that'd be my final answer. That concludes this video. Thanks for watching, guys.